Well, thank you and welcome to this very interesting presentation. This is a KNEC project that was given to the junior secondary learners being asked to make an improvised simple distillation setup. And for our case, we decided to go an extra mile to conduct a real experiment using improvised materials to separate the salt solution. That is, to have salt in one end and water in the other end. As you can see, these are our improvised equipments, our apparatus. We have the bottles, we have the hosepipe, we have a home kettle, we have also used jiko as a source of heat, and we are going to conduct an experiment from the start, which of course involves making that mixture. As you can see, we are adding water to salt inside a kettle, stir to form a homogeneous solution, that is a salt solution, which can easily be separated by simple distillation. So there is a student stirring to just make sure that the whole salt dissolves in the solution. Thereafter, as you can see, a student is tying the end of the kettle, the exit end of the vapor, so that we at least prevent direct touch between the hose pipe that will be joining the kettle to the live condenser and that particular metallic part of the kettle. So as you can see, that is a hose pipe being fitted into the kettle, so that when we'll be heating the kettle, the vapor will get into that particular hose pipe, which is forming part of the delivery tube. So that is acting in that manner. And of course, the bigger bottle that you are seeing is acting as a Liebig condenser. We will have to pour water inside that bottle so that it will necessitate the cooling of the vapor from that particular kettle. And so, as you can see, now this is our Liebig condenser, and we are fitting in a filter funnel. That is an improvised filter funnel, which we made it from the top side of the boiling of the bottle, and it is really working well, playing the role of the filter funnel. So we are adding water to that Liebig condenser to help in cooling the vapor from the kettle. Well, when carrying out an experiment using improvised materials, it is good to be cautious and to know that these improvised materials come with challenges. It is not that easy to just go one way. And for our case, we of course encountered this challenge that you are seeing. Using the vapor is escaping, yet we were to collect the whole vapor. The vapor is escaping, meaning it could not be condensed well by the liquid in the Liebig condenser, and so we were to think very fast and come up with a method to solve the problem. And what the method was is to ensure that the delivery tube gets into another bottle, tied it very well, then insert the bottle inside cold water, so that in case the vapor gets into that bottle without being condensed, it can be condensed by water in the trough, as you can see. Well, that was not enough. As you can observe, that end, having the green top, was also leaking water, and so we were to come up with a way to solve that, and we used a plasticine. As you can see, we are now closing all the loopholes using the plasticine. Plasticine really helped, because even the small loopholes could be well closed by the use of this plasticine. So this is just some the challenges that you will encounter while doing an experiment using improvised materials. And of course, when doing such experiments, you need to be very, very creative, so that when you come up with when you encounter the challenges such as this, you have to think very fast and come up with a way that can be used to solve that challenge in a manner that can also appreciate the improvisation that we are trying to embrace in this particular project. So that is plasticine that we have used to make sure that all the loopholes have been closed. There is nowhere that water can leak out, and also use the same plasticine to fit the hose pipe, which is acting as our delivery tube, to the kettle, so that at least it cannot get into contact with the kettle, which is of course very hot, and also allow all the vapor to enter into that particular delivery tube for effective process, and of course to collect enough distillate on the other end. So that is the just making sure that there is nowhere that vapor will escape from. We have tied using masking tape and of course a plasticine inside to just make sure that there is no escape route for the solution. Now that is done, and this is now our setup ready, a challenge solved, problem solved, and now the setup is ready for the process to continue. Now what we are expecting here is to collect a lot of the distillate, actually all water from the kettle, to come into this other side of the bottle and remain with the salt on the other side. Now this is the process ongoing. As you can see, if you will observe very keenly, you will realize that there is some droplets of condensed water. Learners observing the distillate coming from the delivery tube into that particular collecting bottle. You can see the distillate coming out. What did you say? Lift that distillate, I want to see. Just lift. Wow, a lot of distillate.
Wonderful, I will drink.
Return it slowly. You can see the bubbles.
Yes.
So it means we need to add cold water. Add cold water.
Add cold water.
Now we keep adding cold water to enhance the cooling of the vapor, because of course as the process continues, the water in the lab condenser gets warmer and it cannot cool the vapor effectively, and so we keep adding cold water using the same inlet with the improvised filter funnel to just enhance the cooling process. You can leave
Water at home.
Sorry?
I'll be making my own distilled water.
And then your parents find you.
I will go and teach my mom. I only don't know where I will get a hose pipe.
Somewhere. And a salt.
Salt, we have plenty salt.
We have a lot of distillate, right?
Very many.
So even you can drink every day.
Very much.
No, Likibi, let us try.
We expect to remain with salt in that kettle.
Nothing but the blood of Jesus.
Well, now we have collected a lot of the distillate, enough distillate for that matter, and we are hoping that all the water is off the kettle, and now we want to open the kettle and see if we have our solute, the salt, inside the kettle. Now we are opening. Ready. Wow, wonderful. As you can see, this is pure salt, salt that has remained. There is no water inside here. We have collected the water in the other side of the bottle, and we have remained with the salt on this other end. Now that was our improvised method of simple distillation, and as you have seen, it has all gone well. That is the distillate. It was a mixture of
Salt and water.
salt and water. Now here we have the salt and we have water. Was it successful?
Yes.
Correct. Appreciate yourselves. Clap for yourself. Clap for yourself. And that marks the end of our project. Thank you very much for watching. In case you have any question, just email me in the mail you are seeing on the screen. Please don't forget to hit the subscription button and the notification. Thank you so much. Bye bye.